Okay, so these graphing problems are basically trying to use our transformations and using a couple different transformations on some little graphs. So the first thing I would do is I would pick a couple points on my graph that I kind of see as turning points. So I have these 3 points that I picked, negative 3, 2, 0, negative 3, and 4, 4. So what I'm going to do with these is I'm going to try to transform them. So the first one I have is I want to take this graph of f of x and make the graph of y equal 3 f of x minus 1. Now the key thing with transformations, anything that's happening inside the function, so inside the parentheses, is going to influence the x. And anything that happens outside the parentheses is going to influence the y. So in this case, since it's just f of x, our x's won't change. They will be the same. And our y's will be the ones that are changed. So our y's in this case will be multiplied by 3 because there's a 3 on the outside. And our y's will be subtracted by 1. And by order of operations, I will multiply by 3 first, and then I will subtract 1 second. So if I look at these 3 points I have, so I have negative 3, 2, I have 0, negative 3, and I have 4, 4. So I'll keep the x's the same. They don't change, so they'll still be negative 3, they'll still be 0, and it'll still be 4. Now the y's will change. I will multiply it by 3, and then I will subtract 1. So 2 times 3 is 6. 6 minus 1 is 5. Negative 3 times 3 is negative 9. Negative 9 minus 1 is negative 10. And 4 times 3 is 12, and 12 minus 1 is going to be 11. So what I notice right away is my graph is going to be definitely not big enough, so we'll have to make that a little bigger. 5, 6, 7, 8, 9, 10. And then up here, we can do the same thing. We'll make it a little taller. 4, 5, 6, 7, 8, 9, 10, 11. Now, on Alex, they have the ones that are scaled already, so it doesn't quite have this issue. So now I'll just plot these new points I have. So I have negative 3, 5. So negative 3, but 5 should be here. And then I have negative 3, or 0 and negative 10, which is down here. And then I have 4 and 11, which will be up here. So we've have these 3 points now. These are my new points, so let us connect the dots. So that is my new graph. So what you notice about this graph is when it has multiple transformations, if it has one, it's very easy to see if it's moved up or down. In this case, we stretched it by 3, so it made it much, much, much taller. So think of pulling both ends and stretching it out. And then we took that whole thing and we moved it down 1. So we stretched it up and then we moved it down 1. So that's how we ended up with this graph. Now again, both of these were both influencing the y's. Nothing was influencing the x's. You certainly can have ones that influence the x's as well. So let's look at this one. And again, this is 0 and negative 3. So in this case, we have something inside of it. We have this 2 inside, so that's going to affect the x. And then again, this is on the outside, so this will affect the y. So this one's a simple one. We're just going to add 1 to the y's. Now, when you have the number inside the function, this is where it gets a little different. When you have the number inside for the x, we multiply the y's by 3 because it was on the outside. But when it's in the inside, we are going to multiply the x's by its reciprocal. So we will multiply it by 1/2. That is very, very indicative of things that happen on the inside of the function. I didn't make an example of this, but same thing. If you take x plus a number inside the parentheses, that shifts it to the left. And if it's x minus something inside the parentheses, that shifts it to the right. So if I take these points now, negative 3, 2, 0, negative 3, 4, 4. So I'll first multiply all the x's by half. So that's going to be negative 1.5. That's going to be still 0. And that's going to become 2. So those all get smaller, except for 0, because it's still 0. And then we're going to add 1 for the shift up 1. So that's going to be 3, -2, and 5. So those are my new points. So again, things inside affect the x, things on the outside affect the y. So now I'll just plot these. So -1.5 and 3 is right there. And then we have 0, -2, which is right there. So really, since it's 0, it only gets affected by the stretch up. And then we have 2 and 5, which is going to be up 1 more. So this is our graph. So if you have a whole number multiplied to the x inside the function, it's going to push your graph more in, because it's essentially going to squish it in. If you had a fraction in there, if this was, say, 1/2, then when I multiply by its reciprocal, you're multiplying by 2, so all the x's would get bigger, and it would kind of push out to the sides. So in general, that's how we do the 2 types of stretches for these functions. So hopefully this helps, but if not, obviously let me know. We can do some more.